For problem 4, we're just going to let x equal the number of days. So we're renting a car. It automatically costs $45 flat fee to rent a car, plus you have to pay a per day fee to rent it. And so y would be the cost, or how much we have to pay for renting the car. And initially, the first piece, we see that we're automatically, again, going to be paying $45 before we walk out the door, and then it's $7 per day. So if I rent the car for X number of days, it's going to be 7 times X, but that's only between 0 and 3 days, so 3 days or less. So that's the first piece. And then if we keep the car longer than 3 days, it costs $5 a day. And this is where I like to draw a graph showing the number of days I'm renting the car versus the cost to rent the car. Initially, it's, again, $45 just to walk out the door. If you don't even drive the car at all, you bring it back, it's $45. And so 3 days, though, later, you've got 7x, and so 45 plus 7x. We're just going to draw, we know it's a diagonal line. We know this is a linear relationship, so we know that to get from 0 days to 3 days, we're going to draw a straight line. So there's going to be a cost involved with that. Well, we can easily figure that out. If we rent the car for 3 days, then we're going to be paying $21 plus the $45, so we're going to be paying $66 if we rent the car for 3 days. So we have an ordered pair up here, 3, 66. 3 is the number of days. 66 is the amount of money that we're going to be paying for those 3 days. And then, again, the strategy is just to see what the cost would be if you rent it for one more day. And it's less cost. It's $5 per day, so the rate of change is less than it was in the first 3 days, the rate of change of your amount of money you're going to be paying from here on out. But we do know that if we do rent the car for one more day, it's going to be costing $5 more for that next day. So rental of 4 days would be the $66 plus, again, $5 more, so that's $71. So the ordered pair up here, the ordered pair of this point right here on the rest of this graph would be 4, 71. Well, what we talked about before was that this slope is the rate of change of the new rate of change. So the new rate of change is 5, so the slope is 5. And you could easily find that if you just use the two ordered pairs. 71 minus 66 is 5, over 4 minus 3 is 1. So rate of change in y over the change in x gives us 5 no matter how you look at it. So we have the slope is 5, and then again we've got we're going to use the y minus y1 equals m times x minus x1, the point slope form of a linear equation. We'll use this point right here. The y1 is 66, the m is 5, the x1 is 3, and so we want to solve for y. Y equals, let's try to do this all at once, 5x minus 15 and then plus 66. So I added 66 at the same time I distributed the 5. So we get 5x plus 51. So that's the equation of the second piece. And then when we put them all together, we get y equals, we have the equation, did we have the equation? Yeah, equation of the first piece is the 45 plus 7x. Let's write it as 7x plus 45. That's when you rent the car for at most 3 days. You can't rent the car for less than 0 days, so we let 0 be the first member of the domain restriction there. And then we have this other piece which would be which would have the equation 5x plus 51, and that's again when x is greater than 3 days. And then how much does it cost to rent for 3 days? We already talked about that, and we already talked about what it would cost to rent it for 4 days. And I don't know what in the world is weird about this. I have no clue about that. I did not create this worksheet, but maybe you guys can help me understand what might be weird about this. So nothing seems weird to me. Help me out, though, if you find something.